Sup, homies? My name is my guest, and today we're going to look at self-improving agents. The topic of self-improving agents has been in the ether for quite some time. I would like to highlight just real quick Sierra, who raised $1 billion in April 2026, largely on the back of a product called Ghostwriter, which we will have a look at in a little bit. Now, we've been talking about the Pi coding agent, which of course is a self-modifying agent. So I have a self-improving agent harness. I'm going to show you it in action. Then we'll take a quick break, talk about the architecture that allows the harness to provide self-learning. Then we're going to revisit the demo as it completes. But before I do any of that, let me give you the high level of what Sierra's Ghostwriter does, so you'll have a reference point for what an enterprise self-learning agent is intended to do. So let's listen to Sierra founder talking about how Ghostwriter is self-improving.
Transcripts. You just ask the Explorer agent, how can I improve this metric? Which is what I did. I asked, why are people transferring to live support in our order support journey? You can see the report that the Explorer agent generated here. This is like ChatGPT deep research, but rather than doing research on the internet, it's doing research over your customer conversations.
All right, so that last bit was quite important. He mentions deep research, the feature that ChatGPT introduced very early on. And in particular, I think a very good example or a reference point to kind of making this reality is take a look at Karpathy's research loop, which is about 3 months old, and I think is kind of at the basis for doing self-learning. Right, so broadly, to put a self-learning agent into production, we need to do three things. We need a way to record or create a learning store. There are a bunch of ways this learning store could be created. If you notice in the Sierra example, the store was the customer engagement, that percentage that he used as a basis. It also could be the feedback loop from a prediction that has an outcome, so matching the prediction to the outcome. But broadly, you need a learning store. Secondly, you need a way to eval and score the performance of the predictions and the outcome. So we need to record it. We need a way to evaluate and score it. And then finally, we need the mechanism to implement the updates and then rinse and repeat. All right, without further ado, let's look at our data set. So the problem is going to be as follows. We're going to have an input, a piece of copy, and we're going to take that copy and we're going to structure it. You can imagine, like I do every night with Clipception, I scrape the internet for funding details or funding websites and then structure the data and store it in a database. And so same thing goes for our harness here. We want to take in some copy and we want to provide some structure to it. So from this input, we want to be able to extrapolate or extract a business name, an entity type, and so on and so forth. Okay, so first things first, let's demo the product itself. So this is the agent harness without learning. All right, so the results are in. It ran 13 cases, had an overall field accuracy of 86%. And so what we're going to do now is we're going to actually run the agent harness with learning, and the goal is to create the best prompt such that the percentage extraction is above 90%. All right, same command, except this time we'll add the learning flag, and she's off. Okay, the first results are in. After the first go, we had approximately an 86%. There were a total of 19 field failures. And so what it's going to do now in terms of learning is it's going to target the most problematic field, in this case, the key beneficial owners, where there were 4 records failing, and it's going to try to improve on those. And how this is going to be done, the improvement, is with a state machine. So it's going to test 3 candidates. That's what canned means there. So the 0th candidate actually doesn't improve. Consequence, it's going to try 2 other cases. You can see it says reject there. Let's do a quick walkthrough of the architecture. All of this will be on GitHub, but crucially, we have just a handful of files we care about. In particular, we have our entry point, main, which can be considered the runner. Then we also have our first agent, which handles the actual extraction. Then we have our second agent, which in between rounds, and actually it's probably worth just reading the prompt. So given the current prompt, an eval, and remember that eval is what you saw in the no learning flag, where we basically get just one steady state result. But given the current prompt, an eval report in the field to focus on, give us a new prompt. So all that's handled here by the second agent called agent improve. Then crucially, we have the evals. So after we get some results, we need to evaluate them. And in particular, we use a scoring methodology. Then lastly, to manage the state machine, all of that's handled inside runs. And so in order to determine what ultimately will be the best prompt, we need to generate candidate prompts, improve them, and keep a record of that. Okay, so our learning is done. Let's walk through it. So when we originally ran the loop with learning, our first result had a 86% approximately success rate. And what it did is it took every field that had failing, actually organized them by the fields that were failing the greatest, and then tried to iterate, provided 3 candidates to try to improve the results. So after the first run, we were able to improve our baseline to 94%. Likewise, after we did 3 attempts on beneficial owners, we were never able to get it 100% perfect. We actually had 2 failing, and then we just stopped. Like, this is something to consider. If your main source of improvement is just going to be the prompt itself, you are at a certain point going to plateau. And it's actually an interesting idea that I can discuss in a bit. But ultimately, we got to 94%. Then it switches targets, in this case, to the field control person. It starts with a 94% baseline, iterates, and in that round, everything was rejected. Actually, likewise, in the next few rounds. So we were never able to improve this field. So we keep moving, though. The next field we go to is data formation. Looks like the same thing until the 3rd round when we actually have a pass. And so in that instance, we update our prompt. We now have a prompt that generates 95.4% accuracy. Because we're done with that field, we move on to the next. In this case, primary business activity. Same thing. First round yields nothing. In fact, there were no yields for that particular field. Finally, it looks at annual annual revenue range. And off the bat, in the first round, was able to capture a 96.2% success rate. And so we update our baseline now to 96%. You can see at the end of it, it says no fixable field remains. And then here's entire mapping. It took in 14 rounds on its own. We improved our success rate of data extraction to 96%. On first glance, the use case may seem somewhat trivial, but the truth is it is super annoying to actually do this manually. So I actually, as I mentioned earlier, have a product called Crystal Ball Z, and every night it scrapes the internet for funding news. And I have to actually structure that data. So I scrape it, then I use an agent to structure it. If I would have had a harness like this, it surely would have provided the best extraction with the least amount of effort. Now, self-improving agents are all over the place. In Claude Code, if you're familiar with /loop, this is a good example. A company called Replen.it recently raised a round of funding, and they also provide in the enterprise environment a self-improving agent. And just on a personal note, I have recently been exposed to a project whose phase 3 includes a self-improving agent. So what about you guys? Have you guys seen or worked on a self-improving agent? Have you seen kind of the momentum in that direction? Let me know in the comments. And with that said, guys, I hope you have a great day. Thanks for joining. Like, share, subscribe, and I'll see you homies soon. Peace.